Alright, I'm starting the stream. We're going to start it in a second. Give it like another minute while everyone gets ready. All right, let's start class. Like I said in the chat on Slack, we really only have about an hour of content I'm going to cover today, and then it's pretty much the rest of the day is you guys work on your groups, you work on your projects. When we get to the project time, I'm not going to like send you to lunch or anything. Go to lunch when you want to go to lunch. Frankly, if your team decides you're going to work remote, leave if you want to leave. I don't really care. However you guys get the project done, but make sure you get the project done, right? So that's the important thing. Real quick, Fist of 5, how are people feeling about their projects? Feeling pretty confident about how they're coming along? That's pretty good. Most people are pretty excited. That's great. Again, if you guys have questions when we get to the free work, ask. I know myself personally, I'll just be kind of sitting around doing some coding myself, so I'll have plenty of time to answer your questions and help you out. I don't know if any of the TAs have anything pressing they have to work on. Wouldn't make sense for them to schedule it for now, but, you know, you never know. People do weird things like that. So we'll be here for you, right? We'll be here to answer questions, help you guys get unstuck. Try not to get stuck on one particular problem too long. There's no reason to, and we're here to help you, especially on the days that we are here. The next class, Monday for my class, Tuesday for Daniel's class. There's some more stuff we're going to cover briefly in the beginning before we work on projects. Then we have a week off. So you'll miss the next, so Wednesday, Thursday's off, Saturday's off. But we'll come back to the Monday, Tuesday class where we'll prep for our final presentations. And then the following Wednesday, Thursday, so a week from this next Wednesday, Thursday, we have our actual presentations for Project 2. So your in-class time to work on this is pretty limited. You do have a lot of actual physical time between the presentation and now, but you know, it's holidays, people have got in-laws in town, they've got to make turkeys, they got all kinds of stuff they got to do, so don't plan on that being your safety net, because I know for me, if I was in this class and that 4-day weekend comes around and I'm taking off Black Friday, I'm probably going to be some mixture of hungover and asleep most of the weekend, so I'm not going to get a lot of work done. Anyways, that's just my advice to you. Okay, so today what are we going to talk about before we get working on our groups? A question I have for everyone, and anyone feel free to answer if you'd like. How do you guarantee that every line of code in your program actually works? Testing? How so? No, don't answer that question yet. How do you do it today, right now, before I teach you what I'm about to teach you? You run in the terminal, see the errors, you run your applications a lot, right? Unit testing is the answer, that's what we're going to go over, but you jumped ahead. Come on, give me this. Right now, a lot of us are basically just running our app and kind of doing the things that we programmed, right? Clicking buttons and, you know, manually using Postman to hit our endpoints, and that's well and good, and it does work, technically, but it doesn't scale very well. And as your application becomes more and more complex, it's really impossible for you to know if you're actually hitting every line of code unless you actually debug through every line and you manually see that happening, right? And you could probably imagine debugging, it takes a while when you want to step through everything, see what's going on, and then setting up all the conditions for hitting all of those lines of code. That's a lot of work. So your app grows in complexity, you've got 4 people working on it over the course of 2 weeks. There comes a point where you literally can't have these tests that you run every time someone creates a commit. Think about it. Every time someone pushes some commit to your repo, you have to test everything that it potentially affected again. And sometimes that could be the entire app. So you have to do all of your tests again for every piece of the app to verify that it all still works. and that's just impossible after a certain point, right? So one of the things that we try to do in software development is write unit tests, is what they're called. And basically, we can set up these automated tests that we can just run. They have some pre-supplied data, they have some function or some unit of code that they're going to execute, and they verify the results of that code, right? So maybe in some scenario you expect your code to throw an error, and that is the expectation because it's not what should be happening in your code. You can verify that that's true. Maybe this function's run, it's supposed to, return a sum of two numbers or whatever, right? You can verify that for all different types of numbers you're getting the proper sum, something along those lines. And the best part is you can just run these in the terminal and they run almost instantaneously. So you need to do a regression test on your entire app because someone pushed a bunch of commits that are a little hairy. You can run them all instantly and then know exactly what broke. If they're, doing a good job, they've run them before they push that stuff to your master branch, right? And so they fixed any problems they've caused. But that doesn't always happen. So automated testing is pretty important. I would say a good piece of advice that I've heard is everything in software that you can automate, you should, because we as humans are, we're fallible, right? And we're going to forget to test stuff, we're going to forget to do stuff. It happens all the time, so we shouldn't rely on ourselves realistically. I mean, it's a scary thing to say, but it's true. We're going to mess up. And that's okay. That's just, everyone does. So we should get used to automated testing, and we should want to do automated testing, and you should try to test as much as you can. It does a lot of things, okay? So I just discussed that it helps prevent regressions. It helps you make sure that your app is actually working. You can have a strong guarantee that the code you're writing is actually working, right? And that's a good thing. It also helps you clean up your design. When you're writing a unit test, you are the consumer of your code. Okay, so you're using your own APIs, and immediately you start to write your test, and you can go, wow, this API sucks. I wrote it. I should probably fix it, right? Because you're using it. It's hard to use. You have to change it a lot as you're writing a lot of tests, and it's just a pain. And when you start to see those problems, you can step back and say, why is it so much work for me to test this code? And because it's so much work, that means there's a problem with my design. Now I can change my design. So, unit testing does a lot more than just guarantee your code works. It also helps you design very good code that has very good architecture that can withstand a lot of changes, very robust code, right? So it's an incredibly important thing to do. And the fact that there's so many companies that don't do it regularly is still astounding to me because it is pretty much tried and true that it's going to help your app in multiple ways. There's evidence of that galore. So, any questions on unit testing before we actually start looking at some of it, or why we would want to test, or anything like that? Cool. So the first thing we're going to do before we actually look at unit tests and how to write them in JavaScript is basic error handling. So there's stuff we haven't seen in JavaScript yet. When we've all run into these problems where we're running our code in the terminal or whatever, and then all of a sudden we get this crazy blob of text, says a bunch of weird jumbled stuff, and your app just stops. You're like, cool. And you kind of do that a few times, figure out what's going on, you go fix it, and then you're on your merry way, but it's going to happen again, probably. No one's perfect, right? These are errors, right? They're called exceptions. In JavaScript, there's an error object that is thrown, basically. And everyone's probably seen the throw keyword by now in one place or another and not really known necessarily what it's done yet, or we've seen it and been like, okay, well, what is this exactly? Those are errors, and you can actually throw them yourself, cause the application to terminate, or some part of the application to stop if there's something seriously wrong that shouldn't continue, right? But there's ways that you can handle those gracefully so that your terminal doesn't spit out a bunch of garbage to you. You can handle them so that you can decide what to do, or you can have a nice message to say, hey, this thing didn't work, or whatever, or just prevent your app from crashing altogether, which is ideal. You don't really want that to happen, right? So we're going to look at basic error handling today. So we have this helpers.js class, and it is just going to... it creates this mock read file function, kind of similar to the one that we would use in FS. It's a little different. I'll explain the difference in a moment, but we have this function called mock error, and it just throws a new error. And in the error, it's got a string that just represents the error's message, right? So we've all seen error messages in our terminal. This is this error's message. It's one we've defined, but basically we're going to go ahead and run this read file, and we're just basically mocking out this functionality that the file doesn't exist that you're trying to read. Okay, so, or the file system's corrupted, or something bad happened, right? But we're going to run read file, we're all happy, yeah, read file, and then it explodes. So right in here, this is an example of how we could use it. So we have a process argv2 we're pulling in, that's going to be our file name. And then we're just going to call this read file, and we should see some bad things happen. Let me pull this down. So node try catch example JS etc test. Boom, I get this. This looks familiar to everyone, right? This blob of text. You can actually see where it's pinpointing where exactly that error happened. It's nice because we made the error, so it can tell us a little bit more about it. But it's like, oh, the file system appears corrupted, or the file doesn't exist. Sucks for you. Well, how can we handle that? How can we prevent our app from just exploding and give us a nicer output when this thing kind of happens? Because it's going to happen. Well, there are some keywords called try and catch. They're pretty ubiquitous in terms of programming languages. Almost everyone you'll run into will have some form of this try catch. And what you do is any code that could potentially throw an error, or is potentially scary, or something along those lines that you know could cause the app to crash in a very kind of dangerous and a dangerous way that you're not really expecting. You can wrap it in this try. And then there's this catch block that happens directly after that that literally catches errors. So errors are thrown, and this thing catches them and says, well, we're going to do something with them now. You can kind of program what we're going to do to prevent our app from exploding. So if I run this again with this fixed example, I just get a nice message. It says, okay, well, we couldn't read that file, we logged it or whatever, but the rest of the program was fine. So if I had other logic that happened after here that I wanted to run, always I needed to run, it still can, even though that error was thrown. So try catch is really quite powerful. And we can kind of see, well, let's show some examples how this would work. So we have, let's have a sum, we'll make it set to 0. And let's just console.log sum. Right? So in this scenario, assuming read file works, our sum variable should be set to 3, right? 1 plus 2. If it doesn't work, what's going to happen? If read file throws an error, what happens? Does that sum code ever execute? Let's find out. If I run that again, I'm getting 0 printing out for the sum, because what's actually happening is in this try block, this read file function, it's immediately throwing, we already know that, and everything that happens after that in the try block is just skipped. So what does this mean? Well, this means if read file were to return a file and we needed to use that file, and we want to guarantee that that file exists before we use it, because we do, right? When you go to read it, if it doesn't exist, it's going to throw an error. Any logic that we're going to use that file information on, or use with that file information, can happen after the read file in the try catch, and we can skip it altogether if the read file throws an error. It's a safe way to handle those scenarios where you can't guarantee something's actually going to work the way you want it to, right? And then in the catch, we actually can do whatever we want. So say you go to read a file, and if it exists, you're going to, add some stuff to it, or you're going to parse it or something. But if it doesn't exist, you want to log a nice message. Or say we want to set the sum equal to something totally different, because this is like our error case. Well, now, when we run it again, our sum comes out as 9, because the catch block will run all of its code. Now, if the catch block throws an error, you're out of luck. Don't do that. But the catch block should be relatively safe code, and you shouldn't be doing anything really intense in the catch block. questions on this try catch so far? So again, why don't we go ahead and take this helpers, and I'm just going to comment this out so we can see what the try catch fixed does now that I run it. Now I get that sum of 3 that I wanted to get initially. So read file didn't explode. Nothing bad happened. It's gonna just do everything in the try. Notice it doesn't console log anything in the catch. None of that catch code even happens because there was no error to catch. So just ignore it, right? Don't care about it. Ignore it. Now there's a few things to note about try catches. One, you don't really want to try to use them everywhere, okay? Because it's very easy to take every block of code that could potentially be dangerous and write a try catch around it. But the thing is, the more try catches, the more logic you have. It's quite possible that if an error happens somewhere deep within a set of functions, you actually want it to exit near the parent function. It's just not a good practice to put a try catch literally everywhere. So I don't recommend that. I recommend finding a way to set up your functions so that there's a try catch in one place, or as few try catches as possible in your entire application. It's very possible actually to write a try catch at the very top of your application in your entry point and just use that one if you'd like. Now with Express it's a bit more difficult, but it is sort of possible. Another thing with try catches. So read file, the read file we use with FS is actually asynchronous, right? And it has a callback. This doesn't work with a callback. You cannot try catch around a function that uses a callback. It doesn't work at all. So I can actually show you that. So if we have read file, and in a read file, we are going to just call CB, and CB, well, this one actually is going to work. So this is like our then block or whatever. So I can't just, oh, there we go. So say it takes 1 second, 1,000 milliseconds to run our callback. And before our callback is run, there's actually an error, right? So if we take our try catch here, what we would expect to happen is this to throw an error and to jump into our catch block, right? And then to console log the sum and console log the rest of your program to work. And then when this is done, we can console log this is done. What's actually going to happen, well, let's just run it. It actually ran this sum right here of 3, console logged it, said the rest of your program worked, and then it threw an error somewhere else later. When you have those functions that have a .then or that have a callback that you're using that's asynchronous, the traditional try catch doesn't work. Now, in a lot of the callback functions, like the FS ones, you get an error. And that's kind of your try catch, so to speak. But if you were to try to try catch around your callback, because you're doing something in your callback, you wouldn't be able to catch it that way. So if you have a callback function, you either need to write the try catch inside of it, right? So in this case, we're not going to be able to catch any error because it's happening before the callback. But if you have code in here that could potentially be dangerous, your callback itself needs to have its own try catch. Now that's when we're doing traditional callbacks. When we're doing something with a promise with that .then, it also does not work, a traditional callback try catch. There's a .then function and a .catch function, and a .catch X is your catch. We're not really going to get into that today because we're not going to be working with promises, but just note that on FS read file, write file, and all that, if you're not using the sync version, this won't work as you expect. Okay. So basics of try-catch. Any questions on the basics of the try-catch before we move on? Again, just worry about your normal synchronous code. How do we make our normal synchronous code work okay? We can wrap it in a try-catch, so if anything bad happens, we can catch that error and kind of handle it gracefully. Also, too, note that this mock error, where we can throw a new error, if you ever have something that should not be, right? So there's things called preconditions of your function, right? So say you have a bunch of parameters you take in. Say this read file needs file name, and you don't provide the file name, right? So if not file name, you could do something like new error, a file name is required. This is what's called a precondition. Can we read a file if you don't even give us a file to read? No, we can't. We can actually tell the user of this function right away that what they did is dumb. They shouldn't have done that. They should at least give us a file to try to read. This is a precondition. This is a form of defensive programming where the thought behind it is the programmer who's using this function will run into this error when they are writing their code, right? Because they used it incorrectly. Does it always work that way? No. Sometimes they did something funky and it doesn't happen until the code's running. But it is what it is. This is something you can do because the idea is it is impossible to run read file without a file name. So if you throw an error ahead of time, it's just easier for them to catch it, right? As opposed to waiting until you actually go to read the file and then exploding. So using the throw new error is not necessarily bad, but you shouldn't use it to control the flow of your application, which means you shouldn't use it in place of like an if-else or something. Anyway, try-catch, very basic. I know there's a lot here that we could talk about. We could talk about promises more and callbacks more. I'm not going to talk about it much today. Most of the callbacks you get back from the system calls, like read file and write file, they give you an error that you can then interrogate to see what was going on, and you can rely on that to be your source of truth. Can I continue? When you use .then, if your .then fires, there wasn't an error, right? If your .then callback actually executes, there wasn't an error. If you use a .catch instead of a .then, the .catch looks exactly the same, except it's one parameter is an error. So, for instance, if our read file returned a promise, it might look something like this, right? And then if it has an error, it looks something like this. And in this case, you know that .then didn't fire. This is our try-catch, effectively. There's more to this that makes the then catch kind of powerful, but that's not super important now. Just know that your traditional try-catch does not work on promises or callbacks. Or asynchronous callbacks, I should say. If you write the callback stack yourself, it's different altogether. But that's an aside. You'll figure that one out. Okay, again, any more questions on this before we go to the exercise where you guys are going to play with this try-catch? Cool. Well, we're going to do activity number 9 in GitLab. I'm going to slack out the instructions for you. You're going to basically be creating a function which takes an argument that's a function, and it's going to run that, and it's going to determine if it throws or something along those lines. So you're going to be doing your own try-catch handling and validating that yourself. All right, let's go over this one together. I don't know if Matt meant we can't find a way in terms of driving, or we can't find a way in. Uh oh. Oh my gosh. Yeah. Can't get to it. Yeah. Well, that is a bummer. Curse this parade.
Walking down, putting flyers in windows, and about 2 cars behind, there was a lady walking behind her taking the flyers out.
Nice. The hero we all need, but not the one we deserve. All right, so this activity, we had to take this assert throws function. We had to use it to call this multiply function, and multiply is going to have a check in it to basically say, hey, if the numbers we are passing in to multiply are not numbers, we should throw an error. Very similar to what I said with that file name thing. If there's no file name, we can't read the file. Well, if these aren't both numbers, we cannot multiply them, right? So, assert throws right here. Technically, if we were to just comment out this really quick and get rid of this else, it should work, assuming we give it proper input, right? So we can console log assert throws function multiply 10 10, right? And it shouldn't throw, which is really all we care about at this moment. Did not throw, that's good. We could even console log the output to multiply if we would like. So why don't we do that too? Result. The result was, and then we'll just put it in there. So now when we run it, we can actually even see that our multiply was working. Okay, so what do we need to do? We need to check that our numbers are actually numbers, because if I go ahead and put A in here, well, what's going to happen? That's not good, right? That's not what we want, and that's even worse than not getting an exception from multiply, because then we got to figure out how to handle nan and all the numbers, and that's just a pain. So it's probably better if we actually have this thing throw if these aren't numbers. So let's uncomment this block. What do we need to check? We need to check if x and y are both numbers, right? So how would we do that? Parsint. Parsint, that's actually a good one. We could use parsint. So you could do parsint x. You could say if is nan, right? Parsint x. That means it's not a number. We're going to go ahead and throw. And do the same for y. Another way we could do it, type of. If x does not equal number, or type of y does not equal number, which works functionally the same as the parsing one. That's a really good solution. Then we can say throw new error. X and y must be numbers. Now I want to ask a question here. The original code had this. Is it necessary in this scenario to have an else statement after a block of code throws an error? It is completely unnecessary, and it's actually bad practice because you're adding an unnecessary else block, because literally if that if block happens, nothing else can happen in this function after that. It's throwing, right? That's the whole point of that is we're not going to continue this function. So putting the else after that is not good. Don't do that. So it's just unnecessary. And if it's unnecessary, you shouldn't do it, right? That's kind of the thought we should have. If it's unnecessary, why would I do it? Anyway, that's just an aside. So now if we give it this a and the 10, after I save the file, we should see an explosion. X and y must be numbers. Okay, great. But the goal of this activity was to be able to take that, run the multiply, and safely say something bad or something good happened, right? So what do we got to do to this assert throws to make it more robust so we can say, yes, this threw, there was a problem, or this is good? Yeah? What was that? If I threw...
I don't know if your throw...
Just throw new error?
Yeah, I don't know if I think it's something weird.
Like what?
Well, it didn't throw the error, it got an error on the throw. Yeah, but it didn't actually throw the error. Just had an issue with the word throw.
Oh, no. That is telling you it threw the error. That's where it threw. That's what this pointer is. And here's the error that threw. Yeah, so it threw properly, but yeah, it's a little confusing here. This is where it threw, and normally this wouldn't say throw, right? It would be like some function call that ended up throwing an error or something. So that makes it a little confusing. That was a good point. Thanks for bringing that up. So what do we have to do in this function to be able to say yes or no, this threw, console log maybe, the function threw? What do we got to do? We need a try and a catch. Exactly. Where should we put it? Maybe around this function call? This is the one that's throwing, right? So we should wrap that in a try catch. So I can wrap it in curly braces. Here we can set through equal to true. Oh my gosh, I cannot type today. My class is like so tired of this. Like, dude, you can never type. Alright. What was that? Yeah, never happens. So now we have this try catch. This is going to be a good example of everything that happens with this try catch, right? Because it's going to try to run this function. We're going to get a result back. If it's successful, we can console log the result. Otherwise, we're going to say the function threw, nothing good happened, and we'll console log out a false from assert throws. So if we run it now, the function threw, and threw that was returned is now true instead of false. This is a much, much nicer result than the one right above that, which is basically a bunch of code vomit all over my terminal, right? Now, granted, this code vomit can be helpful, but if you can handle it properly and you know where it's coming from, it's even better. So if I go back to putting in a nice number here, should be okay. Oops, ran clear again. The result was 110, so it actually got the result. It console logged it, and it console logged the false because it did not throw. So again, when it throws, it never executes this line of code right here. As a matter of fact, it never executes this line of code. Therefore, it never executes this result, and then never executes this. So it skips it all. And our catch block says, okay, well, we're going to catch anything that happens in that function, and we'll do this other stuff instead. And when it does run properly, you'll notice that this code does not run at all. So again, they're their own important things to remember about them. Try and catch are their own distinct blocks, so they have their own scope, just like an if and an else and all that stuff. The try will immediately escape and move to the catch when there's an error, exactly at the point of that error. Okay, nothing else in that try will happen after the point of that error if an error happens. And the catch only happens when there is an error inside the try. Now, we have a try catch. Again, if I put the function call that calls the error outside of that try, nothing good is going to happen. Because the function that's throwing the error has to be in the try. So it did me no good. Any questions on this? Cool. The TAs could slack out the solution to that. So what's interesting about this is we have this assert throws function. And you can see it's very manual, right? We have to write a try catch around there. We have to say, did it throw, yes or no? We have to, effectively, we could do this for every function, right? We could write this little assert throws. We could pass in a function, pass in its parameters, make it all, very dynamic so it can take in anything. And it can tell us what functions throw or not. And you could effectively build like a testing suite to see which functions throw, which ones return a nice result. And you could do that totally by hand if you would like. However, it's quite manual to do that, right? So we have jQuery that we've used in the UI on the DOM, and jQuery has a bunch of helper functions to help us manipulate the DOM. We could do it with raw JavaScript if we wanted, but it takes a long time. Is it really worth it? I don't know. I don't want to know all of those things you have to do, right? jQuery can do it quick. You can select stuff with just this $sign selector function and then just manipulate it. It's fantastic. Well, for unit tests, we could do it all manual. We could verify that our application works manually, or we could use some helper libraries that can do it for us. So there's two that we're going to go over in this class. One is called Mocha, like the coffee, right? Your flavored coffee drink. I enjoy mochas. They're great. The other one's called Chai. It's funny. It's a pun on drinks. They go together. And Chai is a suite of libraries that actually allow you to make these assertions, like assert throws. Mocha runs tests. It is a test runner. Chai has assertion functions like this built into it. So we're going to take a look at that. Let me pull it up. I think it's 10. Okay, so if you want to take activity 10 and follow along, you can. If you open it up, you'll notice in our package.json we have two libraries, Chai and Mocha, but they're under our dev dependencies. Does anyone know the difference between dependencies and dev dependencies? Because everything we've done so far has been dependencies, right? Adam, you know the difference?
Kind of.
Kind of? What's the difference?
Using these packages when you just develop, and some packages when you use for production.
Yes. So there are some packages you only use when you're developing code, such as unit testing libraries. Your production release that you give to your client does not need to unit test anything because it should work when you give it to them, right? They shouldn't be running the unit test to verify it works and be like, okay, great, I'll buy this now. No, you should give it to them working, and you do not need to give them Mocha and Chai if they're going to be using the production application, do you? So we have this dev dependency section for things you use explicitly with development only. Testing libraries, things like Gulp and Grunt and Webpack that build your code, those things are dev dependencies. So they're already in the package.json for us, but how could we install packages to dev dependencies? Very similar. npm install. For for the latest version of npm, if you do npm install in the library, it puts it in the dependencies. You can also do save, and that would also save Mocha to the dependencies. But if you want to save it to the dev dependencies, you can do save-dev. That will save it to this dev dependency section. Or if you don't want to remember that, you could just do -D. npm install, D, and then your library, and now it's in your dev dependencies. If I run it, I mean, it's already there, so you're not going to see anything change, but it didn't add it to the dependency section. Same with chai. So now I have Mocha and chai installed. So run npm install if you're going to follow along. But if you need to put something in your dev dependencies, use the -D with the install. -D. So let's look at what we got. We have a very similar function to what we just saw, right? With that useless code in there that I don't like. We're going to remove that. And it just exports this multiply function for us so we can use it all over the place. Now here's one of the things you need to know when you're using the testing frameworks. They happen inside different files, so all of the code that you're testing needs to be exported so that you can import it to the testing file and actually use it. You are now a consumer of your own API, right? So we're going to be able to actually use our multiply function like if we were going to use it in the application, except we get to write a bunch of tests that'll test it and kind of run this secondary code. So usual best practice, we have a source folder, src, right, where we'll put our node code or like our UI code or whatever, right? All of the stuff that is our application. And then we'll have a tests or spec or tests folder, something along those lines, where we'll put our testing code. And in there, we just have a test.js. Now, I'll go over this because it's not best practice to give it a different name. That's not important. We have a test.js. And in test.js, there's a few things that are happening. There's actually quite a lot of code here, as you probably noticed. First, we have this expect. var expect equals require chai.expect. So chai is a very large library that has a bunch of different utilities for testing. One of them is expect. And to get it out of chai, you have to actually reference .expect from it. Otherwise, you'll get all of chai. What expect does is allows us to interrogate results of functions or something to say, we expect this thing to be true or false, to equal this or whatever. So for instance, when we call multiply 2 and 4, we should expect the result of multiply 2 equal 8. A better way to run this, or a better way to write this, in my opinion, as an example, would be like this. So you don't have to read all the inline functions. We should expect our result to equal 8. So it's very much supposed to be how you would kind of read it. It's not perfect, right? It's called behavioral driven development. We're testing the behaviors of these functions, right? But expect is what we use to make these asserts. So we have that assert throws. We can actually, there are other expects we expect this to throw and stuff like that that happen. But this is a real basic one. We expect the result to be 8, and it is. And we'll see in just a moment when we run the Mocha testing framework that it'll show us in the terminal that is the case. So what else do we got? Well, notice that again, we've already seen it in use, but our multiply function is referenced. So we have to require our index.js file, which is just up 1. But then there's a bunch of other weird stuff going on in here. We have this describe function that just seems to appear out of nowhere. And it does. It's a global function that is exposed when you import Mocha into your project. So as soon as you add Mocha in the with npm install, you now have access to this describe function. Describe takes 2 parameters. It takes a string, arbitrary string, and it takes a function, a callback. The first string should represent the function or the module or whatever you're testing. Okay? So if you have one function in a file, you can just say describe multiply. If you have 2 functions in there, maybe you do describe name of file, and then you can have an inner describe multiply. So we could actually do something like this, So we're testing the module. And it's fine. You can nest them all the way down. Describe doesn't do anything other than tell you in the terminal what you're testing. Now you'll notice inside the multiply describe, we have another global function, it. It is used to run a test. Everything in an it function is a test. The callback functions are a test. So it should multiply properly when passed numbers. So we give it a 2 and a 4. They're both numbers. We should get a proper multiplication result out of there. Our callback function is the test. And inside the test, we need some form of assertion. So that's why we use chai. Chai's expect works with Mocha to basically say if this passes, if the result of this expect 2 = 8 is true, then we're going to tell Mocha we're good to go. And Mocha can tell us that that test passed. This one, it should throw when not passed 2 numbers. So in this case, we're given a function, an expect, and I am not going to... My word, who wrote this? So we have this function callback. That takes in a bad multiply, and we expect it to throw some error, right? We don't really care what the message is. We just know that it's going to throw, and you can actually test the message too if you'd like. So what do we do with this? This is all well and good. In our package JSON, we have this script section that we often have npm start, right? And that could be node whatever or nodemon whatever. Well, now there's also another one for test. And in there you can tell the Mocha library what it's going to test. And it's going to default, I think, to the test folder and find everything with those describe functions and just test them. So theoretically, if we do npm test, we get some really nice results out in the console of what's happened. So it tests everything it finds. You'll see that our first describe index is here. Indented in that, we have multiply, the function we are testing. And then we have our 2 tests, which show green check marks saying that they passed successfully. And that was really fast. We ran those tests in 5 milliseconds, probably less than that. It's probably rounding up. 5 milliseconds to run 2 tests. It's not going to get much longer on this multiply function if we added 10 more tests. And then we could test every bit of potential functionality we're running into with this multiply. So what else should we test? Well, it looks like we actually have a string passed into the y parameter, but what if we pass a string into the x parameter? Do we know what'll happen then? We're assuming that it'll work, but we don't know. Should throw when not passed a number as y. And then we can literally take this exact function, copy it, now we've added another test to have an even stronger guarantee that our code's going to work as we wanted. We just run npm test again and boom, more verification. It actually is that simple. You're literally writing a function to just call your code, basically. Now, where it's not simple is, one, you got to learn the libraries, okay? So we all know that that is a pain. But with Mocha, you don't have to learn a whole lot. You just got to have it. You have to learn chai. The chai expect in our case. And I use the expect one on all my production code. I like it a lot, so I do recommend it. Mocha and chai. And then we just have to write the functions. Now this can become hard if our functions are hard to call, right? So if they have a lot of parameters or they require some implicit stuff, or if you call a function and it calls to a database, that means you'd have to have a database there, but how are you going to run that over and over again and get the same results? That's a good question, right? You can't, really. So that begs the question of, is my architecture sound? Deeper questions to ask. We're not really ready for that yet. We're just starting to test, but those questions start to arise when you try to test all your code, and then you can really think about how you've built this application. But anyway, any questions on how this basic stuff works with the Mocha Chai? We're just really kind of dipping our toes into it and seeing the very basic of what you can do, but it's extremely powerful to do this kind of stuff. No? Cool. We're going to move on to activity 11 then. It's called disembowel. It's kind of intense. So we're going to work on that one. And go ahead and work with partners since we're going to be using the testing framework. And we'll go over that in a few minutes. Oh yeah, I'll send out some documentation too. So here's the Mocha documentation. Here's the Chai expect documentation. And I'll just send out Chai in general, so if you want to look at it. So spend some time looking at those docs. Kind of get used to what's going on. You don't have to spend a ton of time because we're not going to be using a whole lot of the functionality, but do spend some time, see what's in there. So remember, in this exercise, we're not actually writing any tests. You don't have to. You can if you want. Just kind of think about how the test should work. And I'm going to kind of cut this one a little short so we can get to writing our own tests. We'll discuss it ourselves, and then we'll do one more activity before you guys work on your projects. Alright, so I didn't give you a lot of time, but we're going to go over this one, and then I'm going to give you guys the time to do the next one yourselves. So this one, we had a function called disembowel, which is supposed to take all of the vowels out of a string. Any string, could be any number of lines, could be a whole file, it doesn't matter. But it should just take every A, E, I, O, U, and sometimes Y, they left that out, and just knock them out of the string altogether. Right? So how could we potentially test that? Well, there's a bunch of tests we could write for this one. There's all kinds of things. We could give it no string, we could give it a long string, but some examples, just some simple examples. The simplest example is, what is our function attempting to do? It is attempting to take all the vowels out of a string and remove them. In this case, it's the simplest form because it's a lowercase string, right? So we should remove all the vowels from a lowercase string. This is lowercase, and it should equal this S, some weird lowercase type abbreviation. Now this is a good test because if we were to write this ourselves, we may not remember that strings can be uppercase and lowercase, right? So you may get in there and go, yeah, I've got this sweet regex that's gonna go through, and it's gonna just remove all of the characters. But in our regex, we're only specifying the lowercase a, e, I, o, u. It's like, oh yeah, it should get rid of everything, no big deal. It should work great. And then we go to run it. We do an npm install. And oh man, we get a whole bunch of errors. It really freaked out there. Uh-oh, well, what happened? Oh, okay, well, we can actually see in this output here, for this first one, expected, this is a lowercase to equal this is a lowercase, but this capital I is still there. Oh, okay, well, it's not actually paying attention to the case properly, or it is paying too much attention to the case. No, it shouldn't. Oh, well, it turns out in regex there's this flag for ignore case. Let's see what that does. Oh, wow, now everything works magically, right? So that's why it's a good example of a first pass test, because you might forget little details like that. So again, we have the same thing from an uppercase string, and we just proved why that can be a problem, right? So we added that ignore case, okay. Either that, or we could have told our regex to look for the uppercase version of those letters as well. And then it has multiple casings in one string, right? How do we solve that problem? So we've got 3 different distinct tests that all do effectively the same thing: a lowercase, uppercase, different case strings. And this is just us trying to think of all of the different ways that we might run this function in production to break it. Now, it's an art in and of itself, coming up with all the different potential conditions that your function could be run under, right? So again, that begs the question of how large should your functions be and how much work should they do? Because can you even tell me that if they're too large? So another design question that comes up from writing these tests. Well, what do we do with numbers? What happens with numbers, right? If we have numbers, I don't know, it's a great question. I have no idea. Well, let's just say we're removing vowels only, so I guess numbers shouldn't matter, should they? So we have this in there, okay, well, it looks okay. We run it, and it turns out that it literally ignores the numbers. 2 and 92 are unaffected. If we had something like this in there, oh, well, now it accidentally it's bringing out the 2, so our regex is incorrect, right? Oh, well, now we need to go fix our regex. So we can go in here, oh, look, oh, accidentally I left the 2 in there, so 2's for some reason are going to be stripped out. Run again. Oh, okay, great, we fixed the test. Now, this last one's interesting. You should cast numbers to strings. There's, I don't agree with this necessarily. This whole function is called disembowel. It's supposed to take vowels out of a string, yet for some reason when you give it a number, it turns it into a string. That does not sound at all like what the function should do. As a matter of fact, if the function doesn't get a string, what should it do? Throw an error, ignore it altogether, return the same thing? I don't really know. It's kind of up to you. I would probably, if I were writing this in production, have it throw an error. Don't give me a non-string. This is literally a string function. You give me a non-string, you're just being an idiot, right? So that's one way to interpret it. But for their example, that's fine. But if that's what you want your functionality to be, okay, well, we want it to take in a number And we want to just convert that number to a string. But you can, but then you have to test for it, right? So, okay, well now we got to try the type of the parameter and make sure that it works. We go and run this. Ooh, what just happened? Okay, well it's not checking to see if that's a string. It's going and trying to run the regex on it, but it's not a string, so it doesn't have a replace function, so it just explodes. Oops, that's bad. Well, now we know we need to go back into our disavow function. We need to add some sort of a check. We run it again. Fixed. You can see probably for how fast I'm going, I know I'm not writing this right now, but it's very iterative. And that's what you want. It's very, very iterative. You want to iteratively test your code as often and as fast as possible. Write a segment of code, test it, bulletproof it. Or, even better, write the test first, then bulletproof it. Different topic altogether. But write a piece of functionality, a very small unit, that's what it's called, unit test, very small function, and bulletproof it. Make sure that thing does not do anything unexpected. And unexpected is what you define in your API, right? So in this case, the disavow, there's different expectations depending on who's writing it. My expectation is if I give it a non-string, it should throw an error. Your expectation is given a non-string, it should just return it as a string, I guess. Right? So there's also that question. What is the expectation that your function should do? Depends on what you want it to do, but make sure you test that thoroughly. Because here's another advantage of tests. I have a disavow function. Say I'm going through this library. Say it's huge. Huge library of string manipulation. And there's a function called disavow. And I'm like, well, what does it do? I could look at the code, but imagine that this is a really long function, and looking through the code's hard, or you don't know regex, so you're like, I don't know what it's going to do, right? You can actually look at the tests. And the tests tell you exactly what it does, doesn't it? Okay, well, it takes all the vowels from a lowercase string. Okay, great. I know already kind of what it does. It also does it from an uppercase string and a mixed case string. Okay, so this function I already know takes a string and removes the vowels. I didn't even have to look at the code. I don't even have to look at the code of the function. I can already tell you what it does because the tests are named well. I can see the output. Oh, it also takes, it ignores numbers. Okay, so it's not going to take out the numbers. Oh, and if I pass in a number, now here's an unexpected one that you wouldn't have thought of. If I pass in a number, I'm going to get a string version out, so it's safe to pass in numbers. Now I know that because I looked at the tests as opposed to interrogating the code. So the tests also make it easier for you to look at just how the tests are implemented and know how something works. So for people you're onboarding, new people who are joining your team, or for instance, there's just a lot of you and you're all writing code and no one has any idea what you just wrote, they can look at your tests and go, okay, I get it now. I see what this function's supposed to do. So there's a lot of value in tests. A lot of value. Any questions on this? Any of the stuff going on in here? Any of the intricacies of Chai or Mocha before we move on to the next exercise? Okay then. We are going to move on to activity 12. There's a function titleize, and you guys are going to be writing a bunch of tests for it. So I'll slack out the instructions. If one of the TAs could slack out the solution to that last exercise, so people can use it as a reference. Yep, and this is activity 12 in GitLab. If you can't remember exactly how to bootstrap your application, use this solution from this activity to start. Okay? So, try to use that to your advantage. Go ahead and work with partners on this because there's a lot to do on this one too. So feel free. All right. Let's talk about this one. This one was actually pretty tough. There's a lot of functionality here if you implement the titleize completely, right? So here is an example implementation of how you could potentially do it. And tests work. They're all passing. I added some actually to the solutions one. I added checks for the input parameters to make sure they actually made sense, right? If it's not a string and has no length, what are you going to do with it? Okay, so first question, what kind of tests can we run on this function? So the function, what I had to do, take in a name, a title of a movie or something, or a book or whatever. And it has to put it in a title format, right? Where the first letter of every word is effectively capitalized. So if you have spaces in your title, every word has to start with a capital, and the rest of it should be lowercase. So what kind of tests can we run on this?
Like they did just split someone's title and then your name, Mr. Smith.
Like Mr. Smith. Okay, so, and what are we validating?
Validating that Mr. comes back capitalized and Smith.
Okay, so we can write a simple test first to just say, verify that the sentence is titleized properly, or should capitalize the first letter of every word, right? That could be the name of the test. And we can pass in Mr. Smith, and we should get a capital M, lowercase r, capital S, lowercase the rest of Smith, right? That's a good example of a test. What else? What other test could we write? How about if we pass in all uppercase, we should get the right casing, right? Or if we pass in 5 words, we should get the right casing. 5 words different than 2 words, and you're testing an entire array, so you should probably do different sizes. What about if you pass in a number? Oops. What should happen? What if you pass in no name, like these? Special characters, what should happen? You know? If a special character is the first character, that's not even what I have covered here. If the first character is a $sign, what do you do? Do you care? Do you uppercase it? What does an uppercase do? Probably nothing, right? Those are all good tests. So some of the tests I have in here, capitalize the initial letter of each word in the input, right? So we have Seth Smith, should be capital S on Seth and Smith. The rest should be lowercase. If you finish the bonus and you appended a period to Mr., Mrs., Doctor, whatever, it should append the period to the leading title, right? So if it starts with Doctor, we should add the period after it. And then we should still get the proper title case. That's another good test. It shouldn't do anything to strings that are properly cased. They should come out exactly the same. That's another good test. It should add periods to things that are properly cased already. It's another good test. Like these little slightly different conditions could cause errors. You could not think of one of them when you're writing the code and then it blows up. It happens all the time. It's actually ridiculous how little things like that can cause so many errors in your code that you never think about. Should properly case mixed strings, right? So this one's got some uppercase, some lowercase, all kinds of weird characters, but it should come out proper. The end. And then these two I added, it should throw when you have invalid inputs. Does anyone else have any other tests they ran that aren't in this list that were good tests? Anyone have any questions on this activity? Testing in general? Why we do this? How to do something specifically? Fist of 5, how are we feeling on testing? Mixed results. Yeah, it's a lot to add. Now, I don't expect you to, and I don't think the TAs do either, to retrofit a bunch of testing into your current projects. Okay, you've already got a lot going on, but if you can add it, it's only going to help you. One, when you go to present, you're less likely to have weird breakages, which happens. Maybe I do what I did to my class last time and be a sadist and display all their projects on Firefox when they only tested for Chrome. Half of them break, right? So not anyone's fault, but you don't think about those things. And that's what unit tests can prevent, right? I never think about those things when I'm making web dev stuff, and I know that I should be, and I'm still like, well, whatever, Chrome. Who uses anything else, right? That's weird. So testing's pretty important. Use these solutions that we've got to help you if you decide to go down that path. I do recommend it. I do recommend on all your new code that you add, you try to test it. It's not going to be easy to do it. I'll tell you that up front. But this stuff is important. We'll look at some more types of tests in the next class session. So from here, you guys are free to go work on your projects. I'm not going to tell you when to go to lunch or anything like that. At 2, if you're still here, I'll come around and say get ready to pack up. And at 2:30, if you're still here, I'm kicking you out of the building. So that's pretty much that. So if you have any questions, come find one of us. We'll help you out. Otherwise, go wherever you want.